All right, here is example problem 3 for coordinate geometry. This says triangle KLM is graphed below. Which set of coordinates could represent the vertices of a triangle congruent to triangle KLM? So we basically want to see which set of coordinates will make a triangle with all the same side lengths as triangle KLM. So let's start by counting the obvious lengths of KM and LM. KM has an obvious length of 4 units, and LM has an obvious length of 3 units. But now we're going to need to do the distance formula to figure out the length of KL. So I'm going to come over here, and I'm going to set up the distance formula. That's basically x minus x, and this is basically y minus y. All right, so now I'm going to need some coordinates to substitute. So I'm going to go over here to K, and K is 1, 1. L is 5, 4. Let me do a quick color code. And then I'm coming over here to substitute. My first x value is 1. My other x value is 5. My first y value is 1. My other y value is 4. Now, to make sure we don't take too long with this problem, I'm going to do all the simplifying on my calculator. You guys can use Desmos. And what you should end up getting is that KL equals 5. So I'm going to go over here and put 5 on that last side, KL. So basically, what we're going to be looking for is which set of vertices here makes a triangle with obvious sides of 3 and 4, and then a distance formula side of 5. So we're going to try and plot these one at a time. I've got an extra graph over here on the right so that we can plot some of these sets. I'm going to use green to plot the first set of coordinates. So those are going to be at 0, 0, 3, 4, and 0, 5. So that's the first set of coordinates. And the only thing obvious here on this green triangle is a side of 5. The other sides would have to be the distance formula. And this isn't matching up what we had over here for KLM. So we're going to cross out that first set. Choice A is gone. The second set, I'm going to use pink. So this set also uses 0, 0, and then negative 5, 0, and then 0, 4. Remember, we're looking for a triangle that has obvious sides of 3 and 4. and then a distance formula side of 5. But on this one, we've got an obvious side of 4, an obvious side of 5, and then one distance formula side. But we're not going to bother to do it because this is clearly not matching up. So let's cross out choice B, and let's move on to choice C. I'm going to use yellow for this third set, and I'm going to go back to the original graph so that things don't get too messy. We've got -1, 1, -4, 5, and -1, 5. Remember, we're looking for obvious sides of 3 and 4. And a distance formula side of 5. Well, there's an obvious side of 3. There's an obvious side of 4. We're on the right track. Let's do the distance formula to make sure that this last side is 5. So I'm going to write the coordinates for those 2 points of the last side. That was -4, 5. And this one was -1, 1. So let me do some quick color coding. The first x value is -4. The other x value is -1. The first y value is 5. The other y value is 1. Once again, I'm going to simplify all of this on my calculator, and you can use Desmos. And what you should get is 5. So that means the last side of that yellow triangle is 5. We've got 3, 4, and 5 as all the side lengths, same as the original KLM. And that's going to make choice C, that third set of coordinates, our answer. The next example problem, number 4, says, parallelogram RSTV has coordinates R00, S24, T60, and V4, -4. Which ordered pair represents the intersection of the diagonals of this parallelogram? Let's start this problem by plotting points R, S, T, and V on the graph at the right, and then drawing this parallelogram. R is 0, 0. S is 2, 4. T is 6, 0. And V is 4, -4. So I'm going to connect these points together to create our parallelogram. The next thing I'm going to do is draw diagonal lines from R and T and S and V to create the diagonals. Now, the key to solving this problem is knowing that the diagonals intersect at their midpoint. Now, where these diagonals intersect on the graph, inside that parallelogram, it looks to be 3, 0. But we would rather mathematically confirm this. So if the diagonals intersect at their midpoint, we should do the midpoint formula. Now we can do the midpoint formula for either diagonal. We don't have to do it for both. We can just choose one. And the one that I'm going to choose is the diagonal that connects R and T. So going back to where we had our coordinates in the problem, I'm going to color code and then I'm going to substitute. My first x value is 0. My other x value is 6. My first y value is 0. My other y value is 0. Now I'm going to simplify. You guys can use Desmos. We get 3 as the x coordinate and 0 as the y coordinate. Now that matches up with what we said the intersection looks like. So I'm going to box 3, 0, and then go over to the answer choices and select answer G. The final example for coordinate geometry is number 5, which says parallelogram QRST is shown below. What are the coordinates of point S? Now, the first thing I'm going to do is write these coordinates a bit bigger so that everyone on this video can see them. T is 4, 6. S has 2 question marks. R is 8, 0. And Q is 0, 0. I'm going to draw a diagonal connecting R and T. And I'm going to find the midpoint of R and T, the midpoint of that diagonal. So setting up the midpoint formula. And let me color code for R and T, and then I'll substitute. So the first X value is 4, and the other one is 8. The first Y value is 6, and the other one is 0. So we can simplify on our calculators or Desmos, and what we should get is 6 for the X value and 3 for the Y value. Remember, this is the midpoint of the diagonal connecting R and T. So I'm going to basically find that midpoint. Draw it there on the picture. And then what I want to realize, and kind of the key to this problem, that midpoint is also the midpoint of Q and S. So I'm going to draw the other diagonal connecting Q and S. That same point is our midpoint. So we're now going to do a technique which we learned back in September called the other endpoint technique. This is going to help us find endpoint S. So here's how I'm going to set up the other endpoint technique. I'm going to write down endpoint Q and its coordinates, 0, 0. And I'm going to leave a little bit of space and then write midpoint. The midpoint that we just found has coordinates 6, 3. And the last thing I'm going to write down is endpoint S. Now, we don't know those coordinates yet, but here's how we're going to figure them out. We're going to look at these two X values and think, what would we need to add to go from 0 to 6? And the obvious answer is we would need to add 6. Now, what I'm going to do is add 6 on the other side. So 6 plus 6 makes the X coordinate of S 12. I'm going to do a similar thing for the Y values. What would we need to add to go from 0 to 3? We would need to add 3. So I'm going to do that again. And 3 plus 3 makes 6. So long story short, S has coordinates 12, 6. And I'm going to go over here and select answer H.